So isn't this the way you're at your base and the leadership just wants a number, okay? We've got this concept in our mind. We don't know what this concept is. Well, I mean, what is a satellite avionics lab complex? What is that thing? What's involved with that? What's it going to require? We don't know. Just give us a number so we can go and work around with that number and try to get money and try to get support and get the... But what the problem is we know once we release that number and it gets to the higher headquarters folks, that number is going to get locked in and it's going to become the commitment to this project. And so this project is going to fail because that number becomes the number against which it is measured for the rest of the time. So this is why we're having this course, this is why we're having this conversation, is what we want to do is we want to set you up as a project manager so that you can characterize and deliver those numbers with some degree of communicating the accuracy along with it. So we're going to talk about cost estimating policy. My name is Tom Glardner. I'm the cost engineer for the faculty. And we're going to talk, when I'm here talking to you, I will be talking to you about cost estimating and the actual process to generate those numbers. And so the objectives of what we want to talk about, we're going to talk today about the policy and where that comes from and what's involved with what is an estimate. And then we're going to talk about the nature of an estimate and what is involved as far as how you relate the accuracy of what you're delivering to the methods and the reason why you're doing it, and all these different things are all related. And we're going to see one chart that kind of rules them all, that shows you the purpose of the estimate, the accuracy of the estimate, the method that you use for the estimate, and the amount of project definition that has to go into that estimate, and relate all those things together. And then we're going to talk about the 3 different methods of estimating. In this course, we only teach you one of them. But you need to kind of know how this method that we will teach you relates to the other methods. And essentially, you need to understand that your estimate has a tremendous impact to the ability of the CE community to compete for and win project funding at the DoD level and above. So we're going to talk about why we're here, what is the policy, a little short discussion of that. Then we're going to get into the definition and philosophies and the structure. So it's a pretty straightforward lesson. Let's start off with why are we here? Way back in the 5, 6, 7 years ago, they started doing a bunch of audits. And the reason they were doing audits is that at the DoD level and at the congressional level, we weren't hitting the mark. We weren't delivering projects for the amount that we told Congress and DoD that we were delivering them for, so the Air Force Audit Agency got involved. There's been a number of studies since then. In fact, they are still ongoing. This GAO audit, this Government Accountability Office, which that GAO is the audit agency of Congress, that was one of the most recent published reports, but there's 2 or 3 other audits that are still ongoing today that are showing the same thing. Let me boil it all down to you in some straightforward findings. 50% of our projects are off by more than 25%. They are unreasonably inaccurate in the estimates that we provide to the approval agency. So whether it be to our own O&M program, whether it be military construction program, whichever program you're in, whether it be at the local levels, whether it be at the air staff levels, whether it be at the congressional levels, 50% of our projects on the average are off unreasonably. And more importantly, 75% of the project managers that we go to and ask them, okay, here is your programming form or your DD form 1391 or whatever. Here's what you said the project would cost us. Where did you come up with that estimate? Show me the detailed estimate that delivers that. And the project managers say, I don't know what you're talking about. And they said, no, this number is a summary of some sort of detailed estimate. Where's that a detailed estimate? And the project manager says, I don't have that. Whether it existed in the first place or not, we don't know. And so that is a major problem. We need to change that, and that's the reason why a lot of policy has come out. Now, the GAO basically told DoD, put them on notice, if you don't take action, Congress will. And the last thing we want is to have Congress jump in and start taking action. So the DoD is starting to apply new policy. They're developing their own reform policies, and the Air Force has developed its own reforms. And the reason this is so important at the higher levels, okay, at the base level, you just give me some money. Give me a lot of money and I will spend it appropriately. I mean, that's the way that base level folks think. I'm at the base level. I've been at the base level. I understand that stuff. But the reason why this is so important at the higher levels is that they've got this thing called an integrated priority list. That's what an IPL is. It's an integrated priority list. And this is just a made up one, but essentially, can you imagine there's thousands of projects sitting up there, and essentially they want to be able to say, here's how much money we have, we'll pay for these projects, and these projects you come back next year. And that's how Congress manages the budgets that they deliver to us, and the military construction program, and the investments in the infrastructure, and the sustainment funding and all that, and that's how DOD manages this, and that's how our AFCEC folks and our Air Staff folks manage the programs that they deliver money for us. They want to be able to handle it this way. But here's the problem. If over half of those projects are off by over 25%, and by the way, those studies, it didn't mean it was 26% or 27%. They were off by hundreds of percent. There was one project that was off by over 800%. So what happens when these projects are off by those amounts of money? Well, essentially, you have no idea in the middle here, or potentially all up and down the program, but you have no idea which projects are going to happen. There may be projects that are funded that we have to unfund, that we have to take off the thing, and that happens all the time. There may be projects down here where at the end, right in middle of June timeframe, we call you up and say, can you execute? Can you execute? And whoever is able to execute, it doesn't matter whether they're the smart project, we're going to try to get that money spent. And so we, at the Air Staff, and at Congress and at DOD, everybody's frustrated because we can't manage the program the way we're trying to manage the program based upon the fact that these estimates are just not there. And more importantly, this is why Congress says our mission is at risk. This is why they're ready to take action. More importantly, you need to understand that these projects have mission associated with them. Maybe there's a new weapon system coming to the base. Maybe there is some sort of operational capability that this infrastructure supports. Maybe there's a vulnerability that we're trying to address. And those things are not happening because we are dropping the ball in the CE community. So this is very important that we address the credibility of our estimates. So let's talk about what the policy is. And essentially, first thing is this 25% rule. You might say, well, what's so important about 25%? Well, essentially, there's a law out there that says if you sent up a number to Congress, it can't vary in 25% without going back to Congress and completely reappropriating or reauthorizing that project. Now, that's a pretty big deal, but then also our policy carries on this. Essentially, it says it can't vary by 25% without, or unless you cross the threshold without getting reapproval. And here's what the bottom line is. It says, essentially, we're defining accuracy by 25%. So if you're in the 25%, we consider that budgetary estimate to be accurate enough. Outside of that 25%, it is inaccurate. Now, you might say that's kind of an arbitrary line, but I'm going to tell you in the commercial world, and I've worked in the commercial world, some of you have worked in the commercial world. In the commercial world, 25% is nowhere near what the commercial world is willing to accept as far as accuracy. In fact, 5% is probably going to cause your company to struggle in an economic world. 10% right out. You're not going to be dealing with 10% inaccuracies in a budgetary estimates because you will go out of business in the commercial world. And so the fact that we in the DoD allow ourselves 25% is extraordinarily generous. So there's a cost estimate improvement program that the Air Force has been working on for the last few years, essentially to address the problems. So what are the problems? They looked at this and said, where are these inaccuracies coming from? Well, there's a lack of an organized process. We don't have a process that says, here's how you generate estimates and here's what we need in those estimates. In fact, this is what the GAO and the auditors are stunned about. What do you mean? Are you telling me that a brand new person who just came out of college or just came out of the shops is going to generate a number and nobody up and down the chain is going to take a look at this thing? Can you tell me that is the, well, the answer is yes. Well, nobody's watching the estimating program. We have inconsistent processes. We We don't have adequate scope development, and that's one of the major challenges of an estimate is you can't estimate without a decent scope, which is part of the reason why this course is in existence, is to get the scope right up front. We have inconsistent tools, and because you have inconsistent tools, that means you're using inconsistent data, you're inconsistent results. All of these are the problems, and part of this, you can also address this as well from base level. We've got people who are pushed into these positions of generating estimates who don't have the adequate background and the experience and the education to generate estimates. Now, they may be qualified engineers, they may be qualified architects. I mean, you guys went off and got a degree for something. I'm an engineer too, I understand that business. But that doesn't mean you're able to walk in and suddenly come up with the estimate of a renovation as you come out of that college. And a lot of folks at the leadership don't understand that. So we need to address this lack of experience. We also have to address the fact that estimates start in ops. Even though the project engineers and project managers and programmers are the ones who finalize projects, they start in ops. And so we need to realize that these initial estimates never die, and we need to address things all the way back at the ops level, which is why we have a 200 course. Now the solution, it's a little bit more words here, so let me kind of break this out for you. We're going to address the process. Just like we had a problem in the process, we're going to address the solution in the process. We're going to adopt international standards for our estimates quality. We are going to mandate certain amounts of scope development. There's a number of different initiatives out there. We already see some of these in the programming world. For example, you have to have a planning charrette for all MILCON and O&M, unspecified minor military construction, as well as any O&M project over $5 million. But they're also going to be implementing this 15% rule, which is 15% project development, and they're going to have definitions of what that means when that comes out in the policy. There's going to be programming estimates that mandate the use of PACEs. There already are today. We'll see those in a couple of slides. And there's going to be a formal independent review and approval. Now, there's an educational suite that we've also implemented. And you're in the ops engineering version of this. This is the one that helps us develop the initial scope and planning estimates. There are two other courses. This one, the 400 course, is mandatory to generate a programmed amount. So if you're going to submit a project for approval up through the chains and it's going to have a programmed amount associated with it, you have to have the 400 course. You can't get by with the 200 course. I've had that question before, and it's not my decision, it's the staff's decision. But the folks who come to me and said, well, can I just take the 200 course and then apply for that with certain waivers of experience and all that? No, you got to have the 400 course under your belt. And then the 500 course is all about those reviewers and approvers. So what is today's policy? This is not the future policy. This is not the cost estimating improvement program. What is currently the policy right now? And it's been in existence, by the way, for several years. This is not new policy. All military construction and unspecified minor military construction, that's that pot of money in MILCON that we use to deal with pop-up projects. All MILCON and UMMC must be estimated using PACEs or another DoD system like M2, and it's got to be to a parametric level of accuracy. Now, this is existing policy. By the way, this was policy back when I was a lieutenant, a long time ago. So this is not new. I get a lot of feedback from this program that says, well, there's a lot of new policy here. Well, no, this is not new policy. This has always been true. We weren't following it, but it's new policy. It's existing policy. Then all facility sustainment restoration projects, modernization projects, in other words, the projects in the O&M program that are over $5 million must be estimated using PACEs to a Class 3 level. Again, this is not new policy. It's been in the business rules for about 5 years now. So it's not something that you can say, well, you're implementing a whole lot of new stuff on us. This is existing policy. And currently, the only way to get access to these PACEs programs is to go through the 400 course, which is, again, not new. The Air Staff has been doing this for some time. Let's talk about what the draft Air Force Guidance Memorandum currently has in it. We'll see how this actually gets implemented. It's not currently implemented yet. When General Allen signs it, then we'll tell you what the real Air Force Guidance Memorandum or AFI or whatever it is says. But you're going to see no change in the MILCON world. All right, so again, not new policy, existing policy. You're in the MILCON and UMMC, you're still going to have to use an estimate using PACES to a Class 3 level, and to be able to get access to those, you have to graduate the 400 course. In the FSRM world, you see this bold here? That's the new stuff. They've dropped it from $5 million to $500,000. In other words, all the ones that you're going to have centrally funded and centrally approved would have a parametric estimate, which we're going to discuss what that means as far as parametric. But in order to get to 25%, you have to have a parametric estimate. And then this is the new thing, but this shouldn't affect the base level. This is primarily a staff level issue. All MILCON and UMMC and FSRM projects that exceed base level approval authority. So if it's going to go to higher headquarters anyway, we must have an independent review and approval. Okay? So this includes all FSRM projects above $5 million, and then repair projects above $5 million, and minor construction projects above $1.8 million, and then again, all MILCON and UMMC, because those are the projects that exceed base level. Now, that independent review and approval is primarily going to be done at the higher headquarters. They will have a contractor and a set of on-staff folks who do that. They've already been doing a number of these projects, but you will have the capability to develop your own independent reviewer or approver at your base level if you have that depth of playing field. So that's something to watch out for in the policy. So that's the policy. Again, not a lot of new stuff here. We're just actually starting to look at it and follow it. Let's talk about what an estimate is. An estimate is a wild guess carried out to 2 decimal places. A good buddy of mine, Ben Matthews, was fond of saying that. And while there's a lot of good humor in that point, there's a message here. And that message is that estimates are both an art and a science. The idea is you're trying to predict the future cost, and there's a science to that. You can come to our 400 course, and we're going to tell you how to open up the cost data and pull out the quantities and the parameters and do all the multiplication and math, and out will come an answer. And that's a good answer. But there's also an art to this, and the art is based upon some realities and understanding what's going on and what's evolving and what changes about your project site that's different than the historical data. For example, if you're building in a facility and you're putting up wallboard, okay, I can tell you what the price of wallboard is per square foot. But if I'm installing wallboard that's elevated, then that price changes per square foot. And it involves a wide range of disciplines. A lot of different people need to be brought into this. And this is one of the big issues that we're trying to explain in this course, is that this is not something you can dump on one person. That one person may be very experienced and have a lot of good expertise and a lot of good knowledge about a particular way of doing business. But as you can imagine, an old carpenter from the shops, which I am an old carpenter, I can do great on coming up with the estimate of wallboard. But you put me on an HVAC system and I am out of my depth. And so for a whole house renovation, I've got to have a whole bunch of people come together and help me out with this estimate, this project definition. As far as estimates, you should be estimating as though you're a prudent and well-equipped contractor. In other words, you should be bidding on the job yourself. You should be as accurate as possible. If you got to get best information possible, which could be product quotes. And you got to maintain it throughout the life of the project. In other words, as you know more information, update it and get that information out. If you have a consultant prepare that estimate, we have a responsibility to review that estimate and validate those results. But likewise, you should also be expecting your consultants to have qualified estimators on their staff. And that should be part of the criteria that you use to select those consultants. In the end, all estimates require independent review and approvals. Now, there's a formal independent review and approval that is part of this whole cost estimating improvement process. We've just discussed it in the previous slides. There's a formal process to do this. But notwithstanding that, every estimate that you do should go to somebody else and say, hey, what did I miss here? What did I not catch? Is this the right assumptions? And so you should never feel like you're the only one who's done this thing. Your supervisor or one of your colleagues, a more experienced colleague, or if an architect engineer firm did it, we need to be validating that stuff. We need to go through and check everything. All estimates require independent review and approval. Because we have to recognize that you're limited. Now, again, you could be a 30-year experienced person who's done this stuff for a long time. Yes, you've got a lot of experience. You've got a lot of breadth to your playing field. On the other hand, you're still coming from a specific discipline. You've still got a certain amount of experience. You may be, for example, electricians, interior versus exterior. Do you work electronics and controls? Do you work cathodic protection? All of those are different types of electrical issues, and you may be best in one area. And then there's a reason why you're generating this estimate. Are you actually generating the estimate for the purposes of negotiations? Or are you generating the estimate for planning purposes? All of that shapes the estimate. So how do you overcome it? Make sure that you got a team. That's why we're talking to more than one person at your base. Make sure that we have internal reviews. That's why you kick things over the fence and build your experience and use the tools that we apply, that we've given you. So with that, we're going to move into the estimate structure itself and talk about the specific types of estimates. For example, let's say you're at a work request review board and you've got this work requirement that comes up. At some point in time, somebody's going to look to some experienced person and say, how much will that run? Is that something we can do in-house? And the shop chief may kick out a number. Yeah, and then make that decision. Yeah, we can do this. At this point in time, the question is, have we actually got an estimate here? Or can we rely on this estimate? Is this estimate going to be right? And I think everybody kind of recognizes that if we're in this environment, probably it's not going to be $50,000 at the end of the game. In fact, if I told you it turned out to be $100,000, you probably wouldn't be stunned. If I told you it turned out to be $45,000, you probably would be very happy but not stunned. Okay? If I told you it turned out to be $150,000, you're probably not happy, but you're not stunned. All right? You realize that number is not, it's just for kicking around the table purposes. It's not a valid estimate. And the reason that that's a dangerous number is somebody's going to write that number down, and a year from now or 2 years from now, nobody's going to remember that that's where the number came from. They don't remember that there's no science behind that number. So let's talk about the ranges and accuracies and all that stuff. This is the chart. I would recommend that if you get a copy of this chart, you keep this chart to explain all things estimating to you, because everything I've tried to package into this one chart. So let me walk through it, and I'll try to stay out of the way of the words as I'm talking to them. There's this thing called a Class 5 estimate. That's an international standard term for the levels of accuracy and all that stuff. So the Class 5 estimate means all this other kind of stuff. Its primary job is a planning estimate. It's when you're at the beginning stages and you just want to know, is this an in-house job, or is this something I need to contract out? Is this something that's going to be in the military construction program? Is this something I can do with the O&M program? You just need to know some feasibility issues and be able to plan out this project. Essentially, you have very little project definition. And we're going to find out that in this course, we're going to do planning estimates. So we're going to do Class 5 estimates. Essentially, you need to know the square footage of the facility that you're building. You need to know where and when. And if you've got that information, you can generate one of these estimates. There's no mandatory required levels of accuracy for these planning estimates. But again, the danger is letting them get into print. Now we're going to use the square foot, square meter method. There's other methods for planning estimates, but the square foot, square meter method is one of the quickest and most straightforward methods of estimating. And it's probably something you're already familiar with a little bit. You can do one of these things in less than an hour. And it's going to generate an accuracy of about 50% high, or I'm sorry, 50% low, or maybe you might be as much as 30% high. So it's got a range of accuracy that is kind of skewed, but 50% is pretty wide mark. All right, so this is the estimate we will use in this course. There's two other types of estimates, and if you come back to the 400 course, we will teach you those estimates. The Class 3 estimate is what you use for budgetary purposes. In other words, we use it for the programming estimates. So if you're generating a project package to send off to higher headquarters to get the approvals, to get the funding, then we use a programming estimate. And you need to have at least 15% project definition. Again, we're going to see that come out in the new DoD policy. They've already talked about it and identified that that's what they want. They're right now trying to define what 15% means. And its required level of accuracy, as I told you before, is within 25%. So how do we get there? You have to use a parametric method. You can't use these higher methods because they don't get you within 25%. The parametric method, also in the commercial world called assemblies, takes you a bit of time. Now, if it's a small little project like that ramp that we saw on the previous page, I could probably knock that out in less than a day. But for a major project like a major renovation, you're probably going to take somewhere up to a week to generate that estimate. But it does get you within the accuracy range that you need to have for a programming estimate. The third level of estimating is this class 1 estimating. Now you might say, where's the class 4 and class 2? Well, there's actually ranges in here. But we in the Air Force primarily focus on these three purposes: the planning, the programming, and then the contracting portion, the actual negotiations with the contractor. If you're going to go head-to-head with the contractor, you have to have an independent government estimate that you can compare against their estimate and say, well, you're off by this. Where did that come from? You need to have a thorough project definition, at least 60%. We will probably expect to see up to 100% on this. And it's got to be as detailed as the contractors. That's what the FAR says, the Federal Acquisition Regulations. It's going to be using unit price methods, which is how you probably figured estimating would be done if you've ever done this on your own private basis for like an addition to your house, or trying to come up with what you're going to lay out for your floor or something like that. You've actually gone in there and measured out and tried to figure out the quantities of carpet or whatever it is. So you're actually figuring out spools of wire and bags and nails and things like that. But that requires a lot of definition, and it takes several weeks to generate a decent estimate in this area. This is why bidding a project for contractors takes a lot of time and a lot of effort, why it's at least a month process. But you can get very accurate with that level of estimate. So again, this kind of lays out all three methods. It lays out the purposes for all three, lays out the accuracies involved with all three, and relates all those together. So it's important that you kind of get this chart under your belt, because this chart is one entire lesson objective that we have in this particular lesson. Now, at this point in time, somebody says, well, what we saw on that previous chart is a WAG, right? All right. What about WAGs, Tom? Well, WAGs, you can call these things a number of different terms, and I've actually seen them written in policy, and they call them a lot of different things: order of magnitude, rough order of magnitude, ROM estimates. You might hear the term SWAG, which is a scholarly WAG. Here's what a WAG is. You may not realize it. It's an acronym. It's been around since I was a lieutenant. It's been around for a while. It means a wild assumed guess. Now, because it's based upon your gut feel and your experience, there's no project development behind this thing. It's got a wide margin for error. Now, some people might say, well, yeah, but I've got a lot of experience and I've got some pretty good gut feels. Well, you might get lucky. I'm not going to tell you won't hit the target by accident someday. Even a broken clock is right twice a day. You've heard of that one. But the issue is, this is not an estimating method. Okay, we're not going to teach you how to do WAGs, and we don't want you to use WAGs, and so stay away from these things. As far as the coursework goes, we're not going to go down the road of WAGs. We're going to teach you the square foot, square meter estimating method. And this is the first method that we will experience in the course. This is again that review of that chart that we saw a couple of slides ago, where I had the class 5 and the project definition and all that stuff related together. It's primarily for the long range planning, and when you initially receive your Air Force Form 332 or your customer service request, or you receive the builder report that says this work's got to be done, this is the point where we're coming up with the initial estimate for us to plan out how this project's going to go. It's not the programming estimate. It should never end up in ACES and TRIRIGA and all those places for programming purposes. But for the initial estimate, for us to plan this stuff out, this is a valid methodology. All you need to know is the type of facility, the size, the location, and the date, and you can come up with the estimate. Now, how does this work? Well, you've probably seen a home buying show or a project or the flippers show or something like that, where they will tell you that in a certain neighborhood, a 3-bedroom bungalow of this size will cost you, well, in this case, $230 a square foot. Okay? That's a great way to come up with a quick rule of thumb of what a particular house will cost. But what they don't tell you on those shows, and what the realtors don't tell you, is that number is widely flexible. And the reason that number is widely flexible, in this particular house, I think I count 1, 2, 3 bathrooms. What if this is a 3-bedroom bungalow with only 1 bathroom? What if this, does this thing have an enclosed garage? This one does. Or does it have a carport? Does this one have a swimming pool in the yard? How many acres of land does it have? What kind of roof is on this facility? What's the construction materials of this facility? There's a lot of question marks that can change that price in a heartbeat. And the realtors know this, but they don't share that with you. All right? They're just going to try to give you that rough rule of thumb. And it's useful to a certain extent, but don't ever hang your hat on that number. That number is not going to be the thing that saves you. Now, why do we do it? Because it's fast. It's quick and easy. It's a quick and easy rule of thumb. Very little input is required. You can generate one of these things, and anyone can do it. This is probably the most attractive thing in the Air Force, is that I can get anybody to do this. All right? But the problem is it's grossly inaccurate. It ignores what goes on inside of the facility. And it can, if we try to use this for more accurate estimate requirements, like a programming estimate, it can mislead your leadership. See, the problem is that these two houses are both dwelling units. And as a result, according to the estimating tools that we have, they would be the same cost if they were the same size. This one being a Fisher house, if you've ever been in a Fisher house, those things are incredibly gold-plated. And this one being a SWA hut, if you've ever been in either, and I've been in both, if you've ever been in either, you know that they're not the same kind of facility. But because the square meter estimating method does not care what goes on inside of it, all it cares is what the size of it is, it would give you the same price for both. And so that's the challenge. I just want you to be aware of the challenges of this method. Now, if you come back to the 400 course, we'll spend several days, in fact, an entire week teaching you how to do a parametric estimate. Remember, class 3, it requires a certain amount of project definition, but it gets you in that 25% accuracy, which is required for programming. It basically takes the facility completely apart into its assemblies. It's little pieces of a facility. So you'll estimate the roof, and then you'll estimate the walls, and then you'll estimate the doors and the windows and all the other parts that go into the facility. And then you assemble them all back together to come up with that cost. The pros is it gets you that accuracy that you need to have. And it's relatively fast. Assembly estimating is much faster than unit price estimating because you don't have to actually count the number of bricks or the number of man hours and things like that. But it requires a very limited amount of development. I just need to have a floor plan, and I need to have a general idea of what kind of facility I'm building. The negative is, though, it does take time. And this is probably the biggest change that our leadership has to address, is that a quality estimate is not an afternoon drill. You need to have some time spent on this estimate. It requires some knowledge. As you can imagine, if I'm going to start making decisions on a built-up roof versus a pitched roof versus standing seam metal versus shingles, that kind of stuff, I need to know a little bit about roofing. And so your average guy who just gets stuck into programming or stuck into ops engineering as an entry-level job is not prepared to do that kind of stuff. And so that's why this estimate is a little bit more challenging for some folks. There's the third method, that's unit pricing, and remember, that's a class 1 estimate. You got to have very detailed project definition up to 100%, and it's generally used for negotiations, for you to be able to negotiate with authority against the contractor. This is where you break down the work into each individual task, and you're going to estimate those individual tasks, like I'm going to put in a slab, I'm going to put in this form work, I'm going to put in this, all the different things. I'm going to excavate some material. All of that, I'm going to break it down into the materials, the equipment, and the quantities, and the labor, and all that stuff that's involved. It's very accurate. It's the way your contractors estimate, and it enables us to negotiate with authority, but it takes a long time to do it. And the bottom line is, at this point in time, I need to know how to do the work in order to estimate it. So for example, as a carpenter, I can estimate the carpentry of a facility with a unit price method. But as not an electrician, and I just had a conversation the other day with an electrician that once we start getting into talking about, you know, the junction boxes and wire ties and things like that, I'm lost, okay? At this point in time, I'm lost. I don't know how many conductors can go in a particular conduit and all that other kind of stuff. So with that, I don't need to be estimating that kind of stuff. Now, curiously, this is something that you as ops engineers, especially the technicians out there, ought to be reassured about. Engineers, believe it or not, are less prepared to do unit pricing than the technicians are. And the reason is because, again, you have to know how to build it in order to estimate it. And so it's very challenging for an engineer who understands the big picture stuff, who's able to determine, for example, I can determine a concrete beam, what the size of the beam is, but do I know how to put up the formwork and to tie all those different rebars together and all that? That's the quantity takeoff stuff that's going to cause me a little bit more challenges than the technicians who do it all the time. You folks come up with, the technicians do, work plans and bills of materials and those types of things all the time. Now, the challenge for the technicians, though, is it does take a lot of math. And you need to understand how to work the math and the tables and the scales and all that other kind of stuff. And this is usually the thing that causes the technicians the greatest amount of challenge in the 400 course. They come in understanding how to do construction, but they are very challenged with the math because it's very math intensive. So, just a quick overview of the policy. We wanted to talk about the policy, why we have it, and then also what the policy is. We talked about what's involved in an estimate. And then we talked a little bit about relating the accuracy to the estimate's purpose, to the class of estimate, to the methodology that you use, the degree of project definition. You remember that one master chart that rules it all, that says here's what the 3 different classes that we're going to focus on in this course. There's 3 different classes, and we talked about how all these things relate. And we broke those methods of estimating down into their different parts. Overall, I want you to realize that your estimates and the estimates that Engineering Flight generates are very important and have a great impact on the credibility of CE and in the ability of CE to manage its programs. So with that, we'll get into the further methods of this course.